that the Pyrrol, because it's Pyrrol, not for any reason, because it's Pyrrol will activate these two positions. Okay? And the nitro, we know that it's electron withdrawing group, it's a deactivating group, and the orientation of the nitro is meta. We do exactly the same than before. This is the ortho, stop because it's a nitrogen. In this side we have the ortho, meta, stop because it's a nitrogen. If it's orientating meta, the nitro will orientate this position. That means we have the Pyrrol. Here we orientate by the nitro and the Pyrrol, and here only by the Pyrrol. That means that the final compound will be okay. This. And this for any group that we studied with benzene. Okay? For example, a ketone will be also deactivating. That means that will orientate meta. A halogen will be activation by resonance, means that will be orthopara. Exactly the same that we did with the benzene. Okay, and the only that we have to consider is the inherent reactivity of the Pyrrol, that is C2. An important thing of the Pyrrol is that it's so active that if, for example, we have this compound, this Pyrrol where we have the two C2 positions already substituted, what will happen is that the addition will take place in the C3 position. Okay? That means this only happens if we have the C2 positions already substituted. Okay? And this is exactly the same than for the furan and for the thiophene. It's exactly the same. Okay, the reactivity will be exactly the same. The only difference is how big is how reactant are, how strong is the reaction. That means this is less reactive than not the Pyrrol. But all that I explained for the electrophilic aromatic substitution of the Pyrrol will happen the same with the furan or with the thiophene. Okay? That means if you remember what you did in the electrophilic aromatic substitution with the benzene, basically you know the reactivity of the Pyrrol, only taking in account that the Pyrrol is more reactive than benzene. And the second thing is that when you are doing the activating groups, okay, the activation of the substituents in the Pyrrol, you have to consider first the inherent reactivity of the Pyrrol. That means we are going to C2, and then when you are calculating orthometapara, the orthometapara always has to be through the carbons and never through the nitrogen. Okay? Good. Remember that the chalk and talk is a summary of the most important things. This doesn't mean that you don't have to check the lecture notes and the videos with the PowerPoint. Okay? Here is only a highlight. Okay, we talk about the electrophilic aromatic substitution, but we also can talk about the nucleophilic aromatic substitution. And here is where we remember what I explained at the beginning of the lecture. We have here the Pyrrol, and we say that it's electron rich. Because if electron rich is okay for the electrophilic aromatic substitution, but is working poorly in the nucleophilic aromatic substitution. It's not a good substrate. If we want to do a nucleophilic aromatic substitution, okay, for example, here we will need to add always, we will need to have always a activating group. Okay, activating group. Remember which are the activating groups. Exactly the same for benzene. The activating group will be basically electron with grabbing groups. Nitro, ketone, ester, etc. Okay, and then we need the leaving group. Okay, remember that fluor is better than chloride, is better than bromide. Okay, that means it's just the opposite than in the nucleophilic substitution bimolecular in the SN2. Here the best group that we can have is the fluorine. Remember why? Because fluorine is the most electronegative. This atom has to be very electronegative in order to generate a density positive charge here. And the second is the smaller. That means when the nucleophile approach, okay, when the nucleophile approach, this is the one that presents less steric hindrance. And how is working? Well, the mechanism is exactly the same than in the aromatic nucleophilic substitution of benzene. First step, and the rate determining step, is the addition of the nucleophile to the aromatic. Okay, and what we have is that a negative charge in this atom, and then basically we regenerate the double bond, the fluorine is leaving, and we have the substitution by the nucleophile. Okay? And again, we need to have an activating group in order that this reaction works, and the activating group has to be in orthopara from the fluorine or from the leaving group. Okay? If it's in meta, this also will not work. This means that this reaction will work well? No, will not work well. These compounds are not good for the nucleophilic aromatic substitution. We can make this work, but will never be a good substrate. Okay? This is the reason that these compounds are not working in the nucleophilic aromatic substitution, or not working well, because they are electron rich. Okay? Well, this is all that I want to explain about the reactivity of the Pyrrol. Remember, if we want to substitute the nitrogen, we need to use base, okay, in order to deprotonate. If we want electrophilic aromatic substitution, okay, remember, it's a very good substrate. And the orientation is C2, okay, this position. And in the nucleophilic aromatic substitution is a back substrate. We need to activate it very well in order to do any nucleophilic aromatic substitution. Okay? And that's all. I recommend you to check the notes, to check which reactions, which condition reactions are the appropriate for the Pyrrol. But remember, you will always be able to use the conditions than benzene. Okay? If worse for benzene, that is a less reactive substrate, with Pyrrol also will react in the paper. That means you can use this click. I recommend to don't use it. I recommend to remember the conditions and reactions for the Pyrrol, okay? And then only remember that when we have a substitution, we always have to calculate the substitution by over the carbons. It means, remember, if we have here X, whatever it is X, this is ortho, and we cannot go through the nitrogen. That means ortho, and the other side ortho metal. Okay? Thank you very much for your attention, and see you soon in the next lecture.